Hello and welcome to today's class. Today we'll be looking at percent yield on stoichiometry. Now, what is stoichiometry? Stoichiometry is the relationship between the product and the reactant in a balanced chemical equation. Now, percent yield. Under this percent yield, here we have the theoretical yield, actual yield, and the percentage yield of product. Now, what is theoretical yield? Theoretical yield, this is the maximum amount or mass of product obtained from a balanced chemical equation. While actual yield, this is the amount of or mass of product that is obtained from a lab experiment or from a real world experiment. While the percentage yield of product, this is the ratio of the actual yield to the theoretical yield expressed as percentage. Now, we say percentage yield of product is equal to actual yield of product divided by theoretical yield of product multiplied by 100%. This is the formula for percentage yield of product. Actual yield divided by what? The theoretical yield multiplied by 100%. Now let's take example on percent yield. Our example 1, we say 5.96 gram of ammonia react completely according to the reaction below. Having the reaction to be ammonia react with carbon dioxide to give urea, to produce urea and water. This is the reaction having their molar mass. The molar mass of ammonia is 17.031. Molar mass of carbon is 12. Oxygen is 16. Urea is equal to 60.056. Hydrogen is equal to 1. So now the question says, what is the theoretical yield for this reaction? So this is the question, which says 5.96 grams of ammonia react completely according to the reaction, having the molar mass, and the question says what is the theoretical yield for this reaction. Mind you, theoretical yield, this is the maximum amount of product, or this is the maximum mass of product that is obtained from what? From a balanced chemical equation. Now, this is solution. The first thing we are going to do is for us to rewrite the reaction. This is the reaction. So now, after writing the reaction, we have to what? Balance the reaction. We have to check whether this reaction is balanced. Now, I have 1 nitrogen, 2 nitrogen, 3 hydrogen, 6 hydrogen, 1 carbon, 1 carbon, 2 oxygen, 2 oxygen. So nitrogen and hydrogen are not balanced. So for me to balance it, I will just write the coefficient of 2. So if I write here the coefficient of 2, I have what? 2 nitrogen, 2 nitrogen. 2 multiplied by 3 is 6, 6 hydrogen. 4 plus 2 is 6, 6 hydrogen. So now this particular equation is balanced. So the next thing we are going to do is for us to find the reacting mass of each compound. So in finding the reacting mass, I will say 2 multiplied by the molar mass of ammonia, which is 17.31, done the molar mass for carbon is what? 12 plus 2 into the molar mass of oxygen, 16. And what is the molar mass for urea? Because this urea is what? 60.05. And the molar mass of hydrogen is 1 plus 2 into the molar mass of oxygen is 16. So this is how we find the reacting mass. So now I will say 2 multiplied by 17.031, I will have 34.062. 2 multiplied by 16 is 32. 12 plus 32 is 44. In grams, 60.05 again, 6. 2 multiplied by 16 is 32 plus 1 is 33 grams. Now we have find the what? Their reacting masses. Next up, what we are going to do is for us to focus on what is mentioned on the what question. From the question, you observe that urea and what? Ammonia are mentioned. So we are going to focus on urea and ammonia. And mind you, we are asked to find the what? Theoretical yield of what? We have to find the theoretical yield of what? Of urea. For this reaction, we are going to find the theoretical yield of urea. So now we are going to say 34.062 gram of what? Of ammonia gives me 60.056. Now, from the question, I have 5.96 gram of ammonia, 5.96 gram of ammonia, which gives me what? X gram of what? X gram of urea. Mind you, we are going to focus on urea because why? Because you say what is the theoretical yield of urea. So now we are given the what? The mass for ammonia, which is this one from the question, and we are asked to find the mass for urea, which is what? The theoretical yield. So now we are going to cross multiply. So we say 34.062 gram multiplied by X gram of urea. X gram of urea is equal to this multiplied by this 5.96 gram multiplied by 60.056 gram. Now I will say now 34.062 gram multiplied by X gram of urea is now equal to, if I multiply this and this, 5.96 multiplied by 60.056 will give me 357.9. So now I want to make my X gram of urea the subject. I will have to divide both sides by what? 34.062 gram. Divided by what? 34.062 gram. This cancels this, so I will have X gram of urea to be 357 divided by what? 34.062 gram. It gives me 10.48, and this 10.48 is equal to the this 10.48 gram is what? Is the theoretical yield. Mind you, we say what? theoretical yield is the maximum amount or mass of what product obtained from a balanced chemical reaction. So this is the theoretical yield for urea. Now let's consider our example 2, which says 9.87 gram of ammonia react completely according to the reaction below if 17.34 gram of urea is produced. What is the percentage yield of product? Now, the first thing we have to do is for us to rewrite the equation. Ammonia reacts with carbon 4 oxide to produce urea and water. After rewriting the equation, the next step is for us to check whether this equation is balanced. Now, I'm having 2 nitrogen, 2 nitrogen. Nitrogen is balanced. 2 multiplied by 3 is 6. 6 hydrogen, 4 plus 2 is 6. 6 hydrogen, hydrogen is balanced. 1 carbon, 1 carbon, carbon is balanced. 2 oxygen, 2 oxygen, oxygen is balanced. So therefore this particular chemical equation is balanced. Next up is for us to find the reacting masses of each of the following compounds. In finding the reacting masses, we say these two multiplied by what? The molar mass of ammonia, which is 17.031. The molar mass for carbon is 12 plus 2 into the molar mass of oxygen, which is 16. The molar mass of ammonia of urea is 60.056, and the molar mass of water 1 plus 2 into the molar mass of oxygen, which is 16. This is how we find the reacting masses. Now we multiply 2 multiplied by 17.031. It gives me 34.062 gram. 2 multiplied by 16 is 32 plus 12, 44 gram. 60.056 gram. 2 multiplied by 16 is 32 plus 1, 33 gram. Now, these are the reacting masses of each of the following compounds. Next up, we are given 9.87 gram of ammonia react completely according to the reaction below. So we are given the mass of ammonia and also we are given the mass of urea. So it means we are going to focus on ammonia and urea. So we say now 34.06 gram of ammonia gives me 60.05 gram of urea, while 9.87 gram of ammonia will gives me 17.34 gram of urea. This is how we go about it. Next up, in finding the percentage yield of product, you need to have your actual yield and the theoretical yield. Now, this is the actual yield. Mind you, actual yield, this is the amount or mass of product that is obtained from a real world experiment or from lab experiment. Or we say actual yield, this is the mass that is given from the question. So this is the actual yield. So for us to find the theoretical yield, we have to make this actual yield as x. We have to take this actual yield as x. So now I will say 34.062 gram gives me 60.05 gram. While 9.87 gram gives me x gram of what? of urea, which is this of urea. Now we cross multiply. 34.062 gram multiplied by x gram of urea, all equal to 9.87 multiplied by 60.056 gram. 9.87 multiplied by 60.056 gram. It gives me 592.75 gram. Now, I want to make x gram of urea the subject. I will have to divide both sides by 34.062 gram divided by 34.062 gram. This will cancel this. So my x gram of urea will be equal to 592.75 divided by 34.062 gives me 17.4 gram. So this 17.4 gram is our theoretical yield. You see in bracket theoretical yield. While this mass is our what? Actual yield. Actual yield. Now, but from the question, we are asked to find the percentage yield of product. So, percentage yield of product is equal to actual yield all divided by theoretical yield multiplied by 100%. Now, what is my actual yield? It's what? 17.34 gram all divided by what is my theoretical yield? Is 17.4 gram all multiplied by 100%. Now, 17.34 divided by 17.4, it gives me 0.996 multiplied by 100%. Now, 0.996 multiplied by 100%, it gives me 99.6. So this is our answer.